All right, number 49 on page 610. By the way, this is my second attempt. I screwed up the first one. I think I had the right technique. It was just, you got to be careful about those little mistakes. So again, I have a double angle here and a quadruple angle there. And I can't really isolate either one of those to use my multi-angle technique with the unit circle. So I need to convert this one into a half angle, into a double angle. So I'm going to use the theorem cosine of 2 theta, the double angle formula, the identity that says it's 2 cosine u squared minus 1. But you got to be a little bit careful here because this is from a double angle to a single angle. I'm going to go from a quadruple angle to half. You just, from here to here, you half the angle. So this is a cosine of 2 theta minus, this is going to be 2 cosine squared of half this angle to 2 theta minus 1. Distribute that negative. And this is where I screwed it up. I combined this and this, even though this one was squared and one wasn't. Or I don't know what I did. So this is a negative 2 cosine squared 2 theta. And then I have a positive cosine 2 theta. Then distribute the 1, you get a plus 1. So I need to factor this. If you're fine factoring it like this, more power to you. Some people like to move it over so that the lead number is a positive, but I'm not going to do that. I don't want to take this step. Negative 2 times positive 1 is negative 2. Factors of negative 2 that add up to 1 is a plus 2 and a negative 1. So I'm going to make the outside product positive 2. I already got a negative 2, so let's make that a negative 1. Those give me a positive 2, and then I'll make this one a negative 1. Looks a little messed up because I didn't move everything over. I probably should have moved everything over, but whatever. So set each of these equal to 0. The cosine of 2 theta is equal to 1. And here the cosine of 2 theta is equal to, move it over, you get a positive 1. Divide by negative 2, you get negative 1/2. Hope I didn't screw this up again. All right, unit circle time. So the cosine is the x-coordinate. The x-coordinate is equal to a positive 1 here. And it's equal to a negative 1/2 here and here. So we kind of get those three solutions that are 120 degrees apart. So let's solve for my double angle. In both cases I have a double angle. So 2 theta is equal to the first solution, which is 0, plus 2 pi thirds k. All right, divide this by 2, multiply this by half. So theta is equal to, 2's cancel, so I get pi thirds k. So there's my angles. That's my infinite solution set. However, I believe I wanted the angles that were on 0 to 2 pi. So I want all the pi thirds, counting by multiples of pi thirds. So I got 0, I got pi thirds, I got 2 pi thirds, I got 3 pi thirds, I got 4 pi thirds, I got 5 pi thirds, and I have 6 pi thirds. However, 6 pi thirds is 2 pi, so that's outside my interval. I think I got it right. I'm going to double check my answer in the book. Woot, it's right.